Hi folks, welcome to day 3 of 9.5. Today we're going to be continuing on in our extra credit unit. Fair warning to anybody that is watching day 3 video before you've watched days 1 and 2 that you have to do these in order, otherwise they're not going to make sense and you won't get credit for them. So make sure that you're going back to day 1 video if you have not already watched that. So in day 1, we learned how to identify A, B, and C from a quadratic, even if it's not in standard form. Yesterday, we learned how to use the quadratic formula, x equals negative b plus and minus the square root of b squared minus 4ac all over 2a, and we use that in order to determine what our roots are, or what our x-intercepts are. And remember, this plus-minus business came from the fact that you'll typically have a positive solution and a negative solution, but not always, and that's what we'll be talking about today. Alright, so the number of solutions that a quadratic has is something that we call a discriminant. The vocab's not too important, but I just wanted to let you know that they do have a name for this. So we have this b squared minus 4ac. This is what's inside our square root. Alright, so this is from the quadratic formula. And this is the discriminant piece. This is what determines how many solutions there are. Alright, so if we have b squared minus 4ac, alright, if that's a greater than 0, alright, then we have two real solutions. Alright, so the graph crosses the x-axis at 2 spots, alright, so 2 real solutions. Real meaning that they're not imaginary, which means that you don't have to take a square root of a negative number. You'll learn about imaginary numbers in advanced algebra. So you have 2 real solutions and 2 x-intercepts. And that makes sense because your real answers, your real solutions in your quadratic formula are the x-intercepts. Alright, so that was if b squared minus 4ac was bigger than 0. If b squared minus 4ac equals 0, you actually had this yesterday in, I believe, your second example. That means that rather than hitting the x-axis and crossing it, it only hits it at one spot. Alright? So rather than hitting it and crossing it twice, twice, like we did in our first example, it only hits it once, all right? And since it only hits it once, we know that there's one real solution, meaning if we, this was our x equals 1/2 solution yesterday, right? The solution that there was only one of them. And that's because the b squared minus 4ac, what was inside that square root, was equal to 0. So if what's inside the square root is equal to 0, you have one real solution or one x-intercept. If you have b squared minus 4ac is bigger than 0, you have 2 real solutions or 2 x-intercepts. The final option is if you have b squared minus 4ac is less than 0, right? That's if what's inside the square root is smaller than 0, physically it relates to something that looks like this, that doesn't cross the x-axis. Alright, and that means that there's no real solutions because the solutions are imaginary. Alright, there's no real solutions and no x-intercepts because it doesn't cross the x-axis. Intercepts. Alright. So let's go ahead and try one out. Let's see if negative x squared plus 4x minus 4 equals 0. Let's see if that is something that has 2 solutions, 1 solution, or no solution. So you can just jump into solving it, but we know that we're looking at the b squared minus 4ac part. So I'm going to identify my a, my b, and my c values. I have an a of -1, a b of 4, and a c of -4. So I have, for b squared, I have 4 squared minus 4 times a, which is -1, times c, which is -4. All right, and we're going to see if this is bigger than 0, smaller than 0, or equal to 0. I know that 4 squared is 16. All right. Now, I have -4 times -1. That gives me +4. All right, so -4 times -1 gets me +4. So then I have +4 times -4. That gets me -16. All right, so I have 16 minus 16, and that equals 0. So we know that there's only one solution. All right, so that's something similar to what you'd be doing. Let's go ahead and try one more. So we have 6x squared plus 2x equals -1. Identify your a, your b, and your c. You should have gotten that a was 6, b was 2, and c is +1 because we need to add that 1 to the other side, so that way this is equal to 0 on the right side. All right, now go ahead and find that b squared minus 4ac. See what that equals. So you should have gotten 2 squared minus 4 times a, which is 6, times c, which is 1. All right, 2 squared is 4. -4 times +6 gets me -24. -24 times 1 is just -24. All right, so I get -20. This is less than 0. So we say no real solutions. All right. So that's all you have to do for those types of problems. To determine how many solutions, you do b squared minus 4ac. See if it's bigger than 0, smaller than 0, or equal to 0. All right? So let's go ahead and recap everything that we've learned about solving quadratics so far. So if we're trying to solve quadratics, here's what we know. We know how to factor. All right. Whoa. We know how to graph. And now we know the quadratic formula. These are all ways to solve quadratics. Let's talk about advantages and disadvantages. So, advantages about factoring. One of the advantages about factoring is that it's very straightforward when it can be factored easy. So, straightforward when easy. I feel like most things are straightforward when they're easy, though. The hard part, of course, is that sometimes you have things that are unfactorable, right? Not everything was factorable in our factoring unit. That was chapter 7, right? So throwback to the beginning of our trimester 3. So sometimes, the nice part about factoring is that when you can factor, it's usually super easy. But sometimes you can't factor. Graphing can be easy to see the number of solutions, all right, as we just saw. And you can use them when approximates are good enough. So this only gives you approximate answers, which can also be like a disadvantage. And in fact, that is the main disadvantage, is that usually it doesn't give exact answers. Right? Like we had to do lots of like rounding and stuff when we were working with like our quadratics, like trying to identify like from the graph. Like I had to pick really good numbers because otherwise it wouldn't give exact numbers, right? It only give estimates. So it's always approximates. But the nice part about graphing is that you can use a computer or a graphing calculator. All right, so you have extra resources that in terms of like quote unquote the real world, you'll probably be using a graphing calculator or a computer program that graphs for you and then analyzes the graph. And then we learned about quadratic formulas, which is really great because they can be used with any quadratic equation, and that's super like useful in terms of math and science as a whole. And it gives an exact answer, which is awesome. Of course, the bad part is it's a formula and it takes some time to do it, right? So that one's time consuming. So students don't typically like that because it takes longer, but it's super straightforward. So those are your 3 main ways that you've learned how to solve quadratics, and I will let you know that this will come up again in advanced algebra. In fact, having an understanding of each of these before you go into advanced algebra is going to be super useful for you. So that's all I have for you today. Tomorrow you're probably looking at like a practice test of sorts, so make sure that you are keeping an eye out for that. Other than that, that's all I got for you. Thanks for watching.